The tallest waterfall on planet Earth is not in South America. It is not the one you learned about in school. It is not any of the famous cascades that tourists travel across the world to see, the ones on the postcards, the ones with the roaring spray and the rainbows. The tallest waterfall on Earth is one that you have almost certainly never heard of, and here's the strangest part. You could sail a ship directly over the top of it, right across the exact spot where it falls, and you would see absolutely nothing. Just gray ocean, stretching to the horizon in every direction. Because the greatest waterfall on this planet is hidden. It is underwater. It is a waterfall inside the ocean itself. And it dwarfs every waterfall on dry land so completely that it almost doesn't seem fair to put them in the same category. It's called the Denmark Strait cataract, and it lies down in the cold, dark water between Greenland and Iceland in the far North Atlantic. Down there, out of sight, an almost unimaginable volume of water is pouring over a hidden underwater cliff and plunging into the deep, and it has been doing so continuously, silently, for a very long time. No spray, no sound you could hear, no dramatic view. Just a colossal, invisible river of water falling through the sea in total darkness, where no human eye will ever watch it happen. And that immediately runs you into a question that sounds almost like a riddle or a trick. How can there be a waterfall underwater? A waterfall is water falling. But if the whole thing is already underwater, if it's surrounded by ocean on every side, then what is falling and what is it falling through? Water can't fall through water. Can it? It sounds like nonsense. It sounds impossible. And yet it is completely real. It is happening right now. And it is one of the most important processes on the entire planet, quietly helping to drive the climate of the whole world. And that's the part that should stop you in your tracks. We live on a planet whose surface is more than two-thirds ocean, and we treat that ocean as if it were basically empty, a flat blue blank between the continents. We map the land in extraordinary detail. We name every mountain, chart every river, photograph every famous view. But the ocean, that enormous majority of our world's surface, remains mostly a mystery to us, because we almost never look beneath it. The greatest waterfall on the planet has been thundering, silently, beneath a busy stretch of northern sea for longer than our species has existed. And for almost all of that time, we had absolutely no idea it was there. Ships sailed over it. Fishermen worked those waters. And the whole time, one of the most colossal natural features on Earth was pouring away directly beneath their keels, completely unnoticed. That's how good the ocean is at keeping secrets. And this is just one of them. Over the next 40 minutes, we are going to solve this riddle completely. We're going to uncover the largest waterfall on Earth, the one no one can see. We're going to find out exactly how a waterfall can exist deep inside the ocean, how water can fall through water, and why this invisible giant, hidden in the cold and the dark, matters more to your life than almost any waterfall you could ever visit. By the end, you'll understand that the ocean is not the simple, uniform thing you probably imagine, and that hidden within it are rivers, cliffs, and cataracts on a scale that puts everything on land to shame. If you want to see the invisible with me, to understand the greatest hidden feature of our oceans, make sure you're subscribed before we begin, because this is a giant that has been hiding in plain sight beneath the waves. And once you understand it, you will never think about the sea the same way again. So let's start by getting our heads around just how big this thing is, because the numbers are genuinely hard to believe. When we think of enormous waterfalls, we think of the giants of the land. We think of the great cascades that plunge from towering cliffs, the ones that have become symbols of nature's power. There is a waterfall in South America so tall that the water falling from its top can break apart into mist before it ever reaches the bottom, the highest uninterrupted waterfall on land. There are waterfalls like the famous ones on the border of North America that aren't especially tall, but carry such a staggering volume of water that the ground trembles and the roar can be heard from far away. These are the champions of the surface world. These are the waterfalls that leave people speechless. And the hidden waterfall in the Denmark Strait makes them look small. Its drop, the height that the water falls, is far greater than any waterfall on land. We're not talking about it being a little bit taller than the tallest land waterfall. We're talking about it plunging down a vertical distance many times greater, a fall measured not in hundreds of meters, but in thousands, from the top of the underwater cliff down into the deep basin below. If you could somehow lift it out of the ocean and stand it up on dry land, it would tower over every waterfall humanity has ever marveled at. A cascade so tall that our most famous falls wouldn't even come close to its shoulder. And it isn't just tall, it's the sheer amount of water involved that truly breaks the mind. The volume of water pouring over this hidden cliff, moving down through the depths, is vastly greater than the flow of any river or waterfall on the surface. An immense, continuous torrent, carrying a quantity of water that makes the mightiest land waterfalls look like a garden tap by comparison. It is, by the measures that matter, the largest waterfall on Earth by a huge margin in both height and flow. The greatest cascade our planet has, and it performs its endless, staggering plunge where not a single person can see it. And it's worth pausing on why comparing it to a land waterfall is so tricky in the first place, because that difficulty is itself part of the wonder. When you measure a waterfall on land, it's simple. You look at where the water leaves the top of the cliff, and you look at where it lands at the bottom. And the distance between those 2 points is the height. You can see it. You can photograph it. You can stand at the base and crane your neck and feel how far up the water is falling from. But an underwater cataract gives you none of that. There is no clean lip you can photograph, no plume of white water tracing the drop, no pool at the bottom you can point to. The height of the fall is the vertical distance the cold, heavy water descends as it pours over the underwater ridge and sinks down the slope into the deep basin beyond. And that distance, measured from the top of the ridge to the depths where the flow finally levels out, is on a scale that simply has no rival among the waterfalls of the land. Even accounting for how differently it behaves, even being careful about how we compare a silent underwater plunge to a roaring cliff face cascade, the numbers still come out overwhelmingly in favor of the hidden one. It is not a close contest. The greatest waterfall on land would be dwarfed, standing in the shadow of this thing like a child beside an adult. And that gap, that enormous margin, is exactly why oceanographers find it so remarkable. The biggest, most powerful example of one of nature's most dramatic features is not on display anywhere. It is tucked away in the cold and the dark, quietly outdoing every famous cascade humanity has ever named. So we have a waterfall that is taller than the tallest and mightier than the mightiest, and yet completely invisible, hidden beneath the surface of the sea. Which brings us right back to that impossible-sounding riddle. To understand how this is even physically possible, how water can pour over a cliff and fall through the middle of an ocean, we have to throw out something you've believed your entire life. We have to challenge a simple assumption so basic that you've probably never once questioned it. The assumption that water is just water. Here is the thing we all quietly assume without ever thinking about it. We assume that water is water, that the sea is just one big uniform mass of the same stuff, sloshing around, all of it basically identical. You imagine the ocean as a giant, even body of water, the same from top to bottom apart from getting a bit colder as you go down. But that picture is wrong, and correcting it is the key that unlocks this entire mystery. Because the ocean is not one uniform substance at all. It is made up of many different kinds of water, and those different kinds of water behave almost like different liquids, layering and sliding and stacking on top of one another, refusing to simply blend into one. What makes one parcel of seawater different from another comes down mainly to two things: temperature and saltiness. And both of those change something crucial. They change the water's density. Density just means how heavy something is for its size, how tightly packed it is. And here's the key fact that everything depends on. Cold water is denser than warm water. When water gets cold, it becomes heavier for its volume, more tightly packed, and it wants to sink. Warm water is lighter, less dense, and it wants to rise and float on top. On top of that, salty water is denser than fresh water. The more salt is dissolved in it, the heavier that water becomes, and the more it wants to sink beneath lighter, fresher water. So put those together, and you realize that the ocean is full of water of different weights. There is cold, salty water, which is heavy and wants to sink. There is warm, fresher water, which is light and wants to float. And these different waters don't just instantly mix into a uniform soup. They form layers. Heavy water settles down low. Lighter water rides up high. And where a mass of heavy water meets a mass of lighter water, there can be a surprisingly sharp boundary between them, an invisible surface inside the ocean where one kind of water sits on top of a different kind, like oil resting on top of vinegar, or cold heavy air pooling beneath warm air. The sea is layered, stacked, divided into waters of different densities, all the time, everywhere. Once you truly understand that, the impossible riddle starts to dissolve. Because now, water falling through water isn't nonsense anymore. If you have heavy, dense water sitting above lighter water, what is that heavy water going to do? It's going to sink. It's going to pour downward, through the lighter water, pulled by gravity, sliding beneath the lighter water because it simply weighs more. Heavy water can absolutely fall through lighter water. It happens because they are not the same. One is denser than the other, and the denser one goes down. That is the secret at the heart of the underwater waterfall. It is not water falling through identical water. It is heavy water pouring down through lighter water, and that is something that can and does happen on an enormous scale. Let me give you a way to picture it that makes it click. Imagine a tank of water, and imagine you very gently pour in some much colder, much saltier water, and you've tinted that heavy water with a bit of dye so you can see it. That heavy dyed water won't just spread out evenly and disappear. It will sink. It will slide down to the bottom of the tank and flow along it, pooling underneath the lighter water, staying separate, a visible layer of heavy water beneath the light. Now imagine that tank has a step in the bottom, a ledge, a drop-off. That heavy water flowing along the bottom reaches the edge of the ledge, and it pours over it, cascading down the step to the deeper bottom below, exactly like a waterfall, except it's happening underwater, one kind of water flowing down through another. That is precisely, exactly what is happening in the Denmark Strait, but on a scale so vast it defies imagination. So now we know the trick. We know that heavy water can fall through light water, and that the ocean is full of waters of different weights. But to build the greatest waterfall on Earth, you need more than just that. You need a very specific setup. You need a source of enormous amounts of heavy water on one side, you need lighter water on the other, and you need a giant underwater cliff for that heavy water to pour over. And it turns out that the geography between Greenland and Iceland provides all three in one of the most perfect natural arrangements anywhere on the planet. To build this hidden giant, nature needs a factory for heavy water, and the far north provides one of the best on Earth. Up around Greenland, Iceland, and the Arctic beyond, the ocean is brutally cold. And remember what cold does. It makes water dense. It makes it heavy. On top of that, when seawater up in these polar regions freezes into sea ice, something clever happens. As the ice forms, it leaves much of its salt behind, dumping that salt back into the water that hasn't frozen. So the water left behind becomes even saltier and therefore even heavier. Cold and salty, the two heaviest making ingredients there are, combined in the same water in vast quantities across the northern seas. This is a colossal reservoir of the densest water in the ocean, chilled and salted and packed tight, sitting up there in the cold and the dark, wanting more than anything to sink. It's worth understanding just how relentlessly the far north manufactures this heavy water, because it's not a one-time event, it's a permanent, ongoing process. Every winter, as the cold deepens and more sea ice forms across the northern waters, more salt is squeezed back into the sea, and more cold, dense water is created. The surface water up there is constantly losing heat to the frigid air above it, constantly being chilled toward its heaviest state. So the reservoir of dense water isn't just sitting there, it's being continuously topped up, refreshed, replenished, an endless production line of the heaviest water in the ocean, feeding the system that drives the fall. That's a big part of why the waterfall never stops. It isn't waiting on any single event. It's fed by the ceaseless, grinding cold of the northern winters, season after season, year after year. And the underwater ridge it pours over is itself a remarkable piece of geography. The sea floor between Greenland and Iceland is not a smooth, featureless plain. It rises and falls. It has ridges and valleys and basins, shaped over vast stretches of geological time. And along this stretch, the floor rises up into that barrier, that sill, standing between the cold northern seas and the deeper Atlantic beyond. Picture it as a long underwater threshold, a raised lip of seafloor. On one side, the water is deep and cold and heavy, piled high against the barrier. On the other side, the floor drops away steeply into the deep Atlantic basin. So when the heavy water finally spills across the top of that threshold, it doesn't just trickle down a gentle slope. It pours over the lip and plunges down a steep descent into the depths beyond, gathering speed and volume as it goes. A broad, powerful, sinking flood of cold water sliding down into the dark. The shape of the seafloor, sculpted over ages, is what turns a simple overflow into a genuine cataract. Without that ridge, without that drop, there would be no waterfall. The geology and the water work together, the land providing the cliff, the cold providing the flood. And the Denmark Strait is not the only place where the ocean does this, though it is the greatest. Along other stretches of the northern sea floor, in other gaps and channels between the land masses of the far north, cold, dense water also finds its way over underwater barriers and spills southward into the deeper Atlantic. These are like sister overflows, other places where heavy northern water pours over a threshold and sinks into the deep. But none of them matches the sheer drop in scale of the Denmark Strait cataract. It stands as the largest of them all, the champion among a whole family of hidden overflows that together feed the cold depths of the Atlantic and help power the great circulation of the sea. Knowing that there are several of these makes the hidden one feel less like a freak accident and more like what it truly is, a natural and inevitable consequence of the way our layered, restless ocean works. And sink it does, but it doesn't just sink straight down and stay put. It gathers. This heavy northern water pools and builds up in the deep basins of the Nordic seas, the cold waters to the north of the line between Greenland and Iceland. It accumulates there, an enormous mass of the heaviest water in the region, held back like water building up behind a dam. Because there is something in the way. Between Greenland and Iceland, running along the seafloor, there is a ridge. An underwater barrier, a raised section of the ocean bottom, a kind of submerged wall or lip that separates the cold, heavy water of the north from the deeper Atlantic to the south. Scientists call a feature like this a sill. Think of it as the lip of a giant underwater dam or the edge of a hidden cliff, holding back an ocean of the heaviest water on the planet. Now you have everything you need. On the northern side of that ridge, an immense reservoir of frigid, salty, staggeringly heavy water, piled up and pressing against the barrier. On the southern side, the deep Atlantic, filled with water that is warmer and lighter and sits higher. And in between, the sill, the underwater lip, the edge over which the heavy water can escape. The stage is set, the dam is straining, and the heavy water finds its way over the top. As the cold, dense water spills over that ridge, it does exactly what heavy water must do. Freed from behind the barrier and finding lighter water on the far side, it plunges. It pours over the edge of the sill and cascades downward, sinking through the lighter Atlantic water, tumbling down the slope of the sea floor into the deep basin far below. This is the waterfall. This is the Denmark Strait cataract, an overwhelming flood of the heaviest water in the north, pouring endlessly over a hidden underwater cliff and sinking into the abyss of the Atlantic. And the vertical distance it descends, from the top of that ridge down into the deep basin, is what makes it the tallest waterfall on Earth, a drop measured in thousands of meters, far beyond anything on land. And this isn't a small trickle sneaking over the edge. The scale of it is what makes it the greatest waterfall on the planet by volume as well as height. A truly immense quantity of water is involved in this overflow, a flow so large that it carries many times more water than all the rivers on land combined pour into the sea. An entire ocean's worth of cold, heavy water, steadily, relentlessly pouring over that submerged ridge and sinking into the deep every second of every day, year after year, century after century. It is a waterfall with the volume of a sea and the height of a mountain range, hidden completely from view. And here's what makes it so eerie. All of this titanic power and motion happens in a way that is utterly invisible and completely silent to us. On the surface of the Denmark Strait, there is nothing to see. A ship sailing over the exact spot would find only the normal gray swell of the North Atlantic, cold and unremarkable. There is no whirlpool, no visible plunge, no roar, no spray, nothing at all to hint that directly below, one of the most colossal movements of water anywhere on the planet is taking place. The greatest waterfall on Earth performs its endless plunge in perfect secrecy beneath a surface that gives away none of it. And if you actually descended into it, into the heart of the cataract itself, what you'd find would be stranger and more haunting than any waterfall you've ever stood beside. Imagine you could descend into it. Imagine you could drop down through the cold gray surface of the Denmark Strait and sink into the water, down to where the cataract is happening, and somehow perceive what's really going on. You would not find what your mind insists a waterfall should be. There would be no crashing wall of white water, no thunderous roar, no clouds of spray hanging in the air. Instead, you would be inside something far more subtle and in its own way, far more unsettling. A vast, slow, silent descent of water all around you, an entire region of the ocean quietly, massively, pouring downward into the dark. Because this waterfall doesn't behave like the ones we know. On land, a waterfall is fast and violent, water hurling itself off a cliff and smashing onto rocks below in a chaos of foam and noise. But down here, the falling is different. The heavy water slides and sinks down the underwater slope, a huge, smooth, powerful flood moving downward through the surrounding sea. It is not a thin ribbon of water on a rock face. It is a colossal, wide, deep current of cold water descending through warmer water, more like an enormous, invisible avalanche in slow motion than a crashing cascade. Silent because it is water moving through water, with no air for the sound to travel through to any ear. Invisible because both the falling water and the water it falls through are, well, water, clear and dark and indistinguishable to the eye. You could be right in the middle of the largest waterfall on the planet and see nothing but dark ocean in every direction, and feel only the cold and the slow, immense pull of the descending flood. Your instruments might register the drop in temperature, the shift in the water around you, but your eyes would insist that nothing at all was happening. That is the deep strangeness of this place. Everything your senses tell you is that you are simply floating in still, dark water, while in reality you are suspended inside one of the most powerful movements of water anywhere on Earth. That is the true nature of this giant. It is not a spectacle. It is a presence. A titanic, ceaseless sinking of water in the cold and the black, felt rather than seen, a process of staggering scale unfolding in complete darkness, where light itself cannot reach. There is something genuinely awe-inspiring about that. The idea that the single greatest waterfall on Earth is not a roaring wonder for tourists, but a silent, invisible, abyssal giant, laboring away unseen in the deep, and that it has been doing so, faithfully, for ages, without a single human ever laying eyes on it as the waterfall it truly is. And think about the sheer, patient endurance of it. A waterfall on land is dramatic partly because it feels alive, roaring, spraying, endlessly moving, a burst of visible energy. This underwater giant has all of that power and more, but none of the show. It expends its colossal energy in silence and darkness, moving more water than you could ever picture, and it does so without any witness, without any applause, without a single ray of light to catch it. Down there, where the pressure is crushing and the cold is absolute and the darkness is total, this enormous flood of water sinks and pours and sinks and pours, exactly as it has for age upon age, indifferent to whether anyone knows or cares. There is a strange kind of majesty in that, a wonder that owes nothing to being seen. Most of the spectacles we celebrate depend on an audience. This one has never had one and has never needed one. It simply is, and it simply does, in the deep and the dark, one of the largest ongoing events on the surface of our planet, unfolding forever out of sight. Which raises an obvious question. If it's invisible and silent, if you can't see it or hear it or photograph it as a waterfall, then how do we even know it's there? How did anyone ever discover a giant that hides itself so perfectly? And the answer is that scientists had to find it not with their eyes, but with instruments, by measuring the invisible. They lowered devices into these waters that could sense temperature and saltiness at different depths. And what those instruments revealed was the hidden structure of the sea, the layers, the cold, dense water in the north, the warmer water in the south, and the dramatic plunge of that heavy water over the ridge. By measuring how the temperature and the density changed from place to place and depth to depth, they could map the flow, trace the overflow of cold water pouring over the sill, and calculate the sheer scale of what was happening down there. They effectively saw the waterfall through numbers and measurements, building up a picture of a thing that no camera could ever simply photograph. They found a mountain-sized cascade by reading the fingerprints it left in the water itself. And it's worth appreciating just how much patience and cleverness that took, because you cannot simply point a camera at this thing and film it. If you sent a submarine down into the middle of the cataract, the crew would look out of the windows and see nothing unusual at all, just dark water, the same as anywhere else in the deep. The waterfall is invisible even to someone standing inside it. So to reveal it, scientists had to build up their picture indirectly, patiently, one measurement at a time. They would lower instruments down through the water on long cables, and as the instrument descended, it would record the temperature and the saltiness at every depth, painting a vertical profile of the sea, a slice through its hidden layers. Do that in one spot, and you learn about that one column of water. But do it again and again in many places across the strait, and slowly a three-dimensional picture emerges. You start to see where the cold, heavy water sits, how thick the layer is, where it begins to tip over the ridge, how it thickens and accelerates as it pours down the far slope. You are, in effect, drawing a map of something you can never see, using nothing but numbers gathered from the dark. And from those numbers, scientists can work out the truly staggering figures: how fast the water is moving, how much of it is pouring over the ridge every second, how far it descends. They can trace the path of the cold flood as it sinks and spreads. They can watch, through their data, a thing that no eye will ever watch directly. It's a beautiful example of how much of science works, not by looking at something obvious, but by carefully measuring the traces and fingerprints that an invisible process leaves behind, and reconstructing the hidden reality from those clues. The Denmark Strait cataract was revealed not by a dramatic photograph, but by the quiet, meticulous work of reading the ocean's hidden structure, layer by layer, until the shape of the giant became clear. In a sense, we know this waterfall exists the same way we know about many of the deepest truths of nature, not because we saw it, but because we measured the world carefully enough that it could not stay hidden. If the idea of scientists discovering an invisible waterfall by measuring the ocean's hidden layers fascinates you as much as it does me, drop the word invisible in the comments so I know you're still with me, because we've now uncovered what this giant is and how we found it. And that leaves the most important question of all. Not what it is, but why it matters. Because this hidden waterfall is not just a curiosity, not just a strange piece of trivia about the deep sea. That silent plunge of cold water in the Denmark Strait is quietly connected to the fate of the entire planet, part of a vast machine that shapes the climate of the whole world. And to see how, we have to zoom out, all the way out, from this one dark cliff in the North Atlantic to the entire globe. To understand why this hidden waterfall matters so much, you have to see it not as a single feature, but as one part of something enormous. Because the sinking of all that cold, heavy water in the far north is not a dead end. That water doesn't just pour into the deep Atlantic and stop. It becomes the beginning of a journey that spans the entire planet and takes not days or years, but centuries to complete. When that dense, frigid water plunges over the ridge and sinks into the deep basin of the Atlantic, it forms a vast mass of cold water at the bottom of the ocean. And that water has to go somewhere. Pushed by the constant arrival of more sinking water behind it, it begins to spread and flow slowly, deep along the ocean floor, creeping southward through the Atlantic depths. This deep, cold current travels down the length of the Atlantic, moving through the dark far below the surface, part of a slow, deep flow of water heading away from the poles toward the rest of the world. The waterfall, in other words, is one of the great pumps that helps power the deep circulation of the entire global ocean. And this global circulation, this slow movement of water through the deep sea and back along the surface, is one of the most important systems on the planet. Scientists sometimes describe it as a great conveyor belt, an enormous planet-spanning loop of moving water. Cold, heavy water sinks in the north, as we've seen, and flows away through the deep. Elsewhere in the world, that deep water eventually rises back toward the surface. Surface currents carry water across the globe, warming and cooling, sinking and rising, in a loop so vast it connects every ocean on Earth and takes water on a journey lasting hundreds and hundreds of years to go all the way around. It is one continuous interconnected system, moving unimaginable amounts of water around the entire planet, and the sinking of cold water in places like the Denmark Strait is one of the engines that keeps the whole thing turning. Now here is why that matters to you, wherever you happen to live. This great ocean circulation doesn't just move water, it moves heat. The surface part of this system carries warm water from the tropics toward the higher latitudes, and as that warm water travels, it releases its heat into the air, warming the lands it passes. This is a huge part of why certain regions enjoy far milder climates than they otherwise would. The movement of warm water across the ocean, driven and balanced by the sinking of cold water elsewhere, helps spread the sun's heat around the globe, softening the extremes, warming places that would otherwise be bitterly cold, shaping the weather and the seasons that entire civilizations depend on. The ocean is not just a passive pool of water sitting between the continents. It is a gigantic circulating engine that redistributes heat across the whole world, and it profoundly shapes the climate that all of us live in. Let's follow that cold water on its journey, because it really is one of the great voyages on the planet, even if no one ever sees it. After the heavy water plunges over the ridge and sinks into the deep Atlantic, it begins to move south, hugging the bottom, a slow river of cold water creeping along the ocean floor. It travels enormous distances this way, flowing through the deep Atlantic, mixing gradually with the waters around it, part of a vast, slow-moving mass of deep, cold water spreading away from the north. This deep water eventually makes its way toward other oceans, joining a global network of deep currents that wind through all the world's seas. And in various places around the globe, far from where it sank, that deep water slowly rises back toward the surface, drawn upward over long stretches of time. Once at the surface, it can be warmed again by the sun and carried by surface currents back toward the poles, where eventually it may cool and sink once more, and the whole cycle begins again. A single parcel of water might take many centuries to complete this entire loop, sinking in the cold north, creeping along the deep sea floor, rising in a distant ocean, riding the surface currents, and finally returning. It is a journey measured not in miles, but in centuries, a planetary circulation so slow and so vast, it's almost impossible to hold in your mind. And this is why processes like the sinking of water in the Denmark Strait are watched so closely by scientists. Because this great circulation, this conveyor of heat and water, is not guaranteed to run at the same pace forever. It depends on that delicate balance, on cold, salty water being heavy enough to sink in the north. And the strength of that sinking depends on the conditions up there, on how cold the water is, on how salty it is. If those conditions shift, the balance that drives the whole system can change with them. This is why researchers pay such careful attention to the northern seas, monitoring the temperature and the saltiness, keeping watch on the engines of the deep circulation. They are studying in effect the health of one of the most important systems on the planet, a system that helps regulate the climate that billions of people live within. And features like our hidden waterfall are a key part of that system, which means that this silent, invisible, out-of-sight giant is not only a wonder in its own right, it's also a piece of the machinery that keeps our world's climate in the state we've always known. Understanding it isn't just satisfying curiosity. It's part of understanding how our whole planet works and how it might change. And the sinking of cold, heavy water in the north, the very same process that creates our hidden waterfall, is one of the crucial places where this whole engine is driven. The overflow pouring over that ridge between Greenland and Iceland is part of what keeps the deep circulation moving, part of what keeps the warm currents flowing at the surface, part of what keeps the heat spreading around the planet. So this silent, invisible waterfall in the dark is quietly linked to the warmth of distant coastlines, to the mildness of far-off winters, to the great planetary system that helps make huge parts of the world comfortable to live in. A thing that no one can see in a remote and freezing sea is threaded into the climate of the entire globe. And it's worth sitting with just how interconnected this makes the whole planet. It means that what happens in one small freezing strait between Greenland and Iceland is quietly tied to conditions thousands of kilometers away. The warmth of a distant coastline, the mildness of a far-off winter, the pattern of rains that feed distant farmland, all of it is threaded, in some small part, through this great circulation that the northern sinking helps to drive. Nothing about the ocean is truly local. A change in the density of water in the north can send ripples, over years and decades, through a system that touches every sea on Earth. We tend to imagine the different parts of our world as separate. This ocean here, that continent there, this climate, that weather. But the truth revealed by following the water is that it is all one connected system, one enormous, slow, breathing machine. And the hidden waterfall in the Denmark Strait is one of the places where you can see, if you know how to look, just how deeply everything is joined to everything else. Take a moment to really feel the strangeness and the wonder of that. The largest waterfall on the entire planet is one that no human being will ever stand beside and watch. It makes no sound we can hear. It throws up no spray. It offers no view. It hides beneath an ordinary stretch of gray northern sea, betraying nothing of its presence to anyone passing above. And yet it is greater than every waterfall on land combined in its scale, and more important than all of them put together in its effect on our world. It is a giant that survives entirely in the unseen, doing planetary work in perfect obscurity. And that, in the end, is the real lesson hiding in the cold water of the Denmark Strait. We tend to think we know our planet. We think the great wonders are the ones we can visit, photograph, and post, the towering falls and the famous peaks, and the sights that draw the crowds. But the truth is that some of the most colossal and important things happening on Earth are completely invisible to us, unfolding in places we never look, in the deep ocean, in the dark, on scales that dwarf anything on the surface. The greatest waterfall in the world is proof of that. It reminds us that the ocean is not a simple, uniform thing, but a layered, structured, living machine full of hidden rivers and cliffs and cataracts, and that beneath the plain gray surface of the sea, our planet is running processes of staggering size and importance that we are only just beginning to understand. So the next time you look out at the ocean, at that flat, featureless expanse of water reaching to the horizon, remember what's really down there. Remember that the sea is not one thing but many, stacked in invisible layers, moving in hidden currents. Remember that somewhere in the cold north, right now, a waterfall taller than any mountain cascade and mightier than every river on land is pouring silently into the abyss, unseen and unheard, quietly helping to keep our whole world turning. The greatest waterfall on Earth is invisible, but now, at last, you can see it. If this changed the way you look at the ocean, tell me in the comments what surprised you the most, and subscribe, because the planet is full of these hidden giants, and there is nothing I love more than dragging them out of the dark and into the light, one by one. The sea is keeping its secrets right now, beneath a surface that looks like nothing at all, and there are more of them down there than any of us has ever guessed. We have only just begun to look.